So hello everyone, welcome to my channel Engineering Chronicles of Plant Design. So chronicle number 2. So today's video is all about piping. What are pipe? What is pipe? What is pipe material? What is pipe fittings? Different types of fittings. So in detail we will discuss about all these things in today's video. And for people who are very new to piping, this video will be very helpful to them. Topics covered in today's video are classification of pipes, pipe materials, pipe specifications, pipe dimension, and pipe fittings. So moving on to today's first topic, that is classification of pipes. So pipes are mainly classified depending upon the manufacturing process. So if you see welded pipes and seamless pipes. So in a welded pipe, there will be a joint like this, and depending upon this joint, we call this pipe as a welded pipe. A seamless pipe will be without joint. The manufacturing of seamless pipe is a extrusion process in which the pipe is produced without any welding. And seamless pipes are mostly used where the service is a lethal. For example, hydrogen sulfide gas, H2S gas. And welded pipes are further classified into two types. So ERW, EFW, HFW. So ERW means electrical resistance welding. EFW means electric fusion welding. HFW means high frequency welding. And SLW is a very commonly used process in a manufacturing that is called submerged arc welding. In the market, ERW is the most commonly used pipe, and SAW is further classified into two types: straight saw, helical, or spiral saw. So helical, if you see this picture here, this joint is a helical joint, and this will be welded helically. Hence, this is called as helical saw. In a straight saw, it will be same as this pipe, and straight saw is further classified as double seam and single seam depending upon the welding. Let's discuss further about selection of pipe materials. So pipe materials are mainly selected depending upon types of fluid, service temperature or inlet inside fluid temperature, operating pressure, atmospheric condition, and corrosive nature of the fluid. So atmospheric condition, why I have put here is because, for example, if you are having a pipe in a atmospheric condition where the temperature goes beyond minus 25 or minus 40 degrees centigrade. So if you have heard about the design condition which we say MDMT, mean design metal temperature. If your metal MDMT is not colder than the atmospheric condition, then your pipe will become brittle and the conditions will fail. Hence, it is very important to check with the atmospheric condition of the pipe before selecting pipe material. So corrosive fluid is also important because if the fluid is corrosive in nature, so normal pipe will not sustain. We have to go with the anti-corrosive material. This first three is a very common operating conditions depending upon which we select the pipe material. So pipe material properties are further classified into ultimate strength, yield strength, elasticity, percentage elongation, hardness, toughness, creep resistance, fatigue resistance. These are some of the material properties based on which we'll also select the pipe material. So pipe material classification. So pipe material classification are mainly divided into three main categories, that is metal, non-metal, and lined or cladded. So what is metal? It is a ferrous pipe or non-ferrous pipe. So ferrous means iron content. Depending upon the iron content, we define metal pipe into ferrous pipe or non-ferrous pipe. So ferrous pipes are such as cast iron, carbon steel, alloy steel, stainless steel. Non-ferrous pipes are such as copper alloy, nickel alloy, aluminum alloy, or other kind of alloy. So non-metal pipes are PVC, CPVC, UPVC, HDP, GRP pipe, FRP pipe, cement pipes, and the lined or clad pipes are it can this pipe can be non-metal or metal pipe with a cladding inside. For example, we can use carbon steel pipe and we can have PTFE line inside. Let's discuss further about classification of carbon steel. So carbon steel material is a mostly commonly used material in a piping industry. It is further classified as low carbon steel, medium carbon steel, and high carbon steel. If the carbon content present inside the material is from 0.05% to 0.25%, we call as a low carbon steel. And if the carbon percent is from 0.25 to 0.35%, we call it as a medium carbon steel. And if it exceeds 0.35%, we call it as a high carbon steel. High carbon steel are very brittle. Medium carbon steel are very commonly used material, and 0.35% is a threshold beyond which we are not able to do welding. So these are some of the examples of carbon steel material: ASTM A, 53A, 53B, 106A, 106B, 106C. So if you see this material, these are commonly used in a piping industry, carbon steel material. And we have further examples also, and these are used depending upon the conditions of the process. So we discussed about classification of carbon steel. Now let us see what are classification of stainless steel. So stainless steel is also very commonly used in the fabrication industry. So first classification is austenitic stainless steel, ferritic stainless steel, martensitic stainless steel, precipitation hardened stainless steel, duplex or super duplex stainless steel. So let's see more about austenitic stainless steel. So austenitic stainless steel is a non-magnetic in nature and has very high corrosion resistance. It is excellent in weldability, formability, fabrication ability, and ductility. It has high corrosion resistance at temperature up to 1500 degree Fahrenheit or 800 degree centigrade. Useful for both low and high temperature service. This type of steel is hardened by cold working. It has face-centric cubic structure. That is, this is the manufacturing process. Possess high impact strength at low temperature. So earlier I said atmospheric condition of a pipe material. So here this material has a very low MDMT, and this type of SS material is widely used in a process industry. And some of the examples are 304, 316, 309, 321. So further let's see about ferritic stainless steel. So ferritic stainless steel is in magnetic in nature and contains high carbon, therefore it is brittle and relatively poor corrosion resistance compared to austenitic stainless steel. Non-hardenable by heat treatment. It has body-centered cubic coarse grain structure. So ferritic stainless steel has a high resistance to chloride stress, corrosion cracking. So it is used in marine, petrochemical, heat exchangers, furnace application where the chloride content is there. And some of the examples are 409, 430, 439, 444, 446. So next is martensitic stainless steel. So martensitic stainless steel has high hardness and poor corrosion resistance than austenitic stainless steel. Heat treatable to high hardness level. Crystallographic form distorted structure. It is used in manufacturing of sport knives and multiple purpose tools, also in a medical applications. So examples are 405, 410 and 420. So next is precipitation hardened stainless steel. So precipitation hardened stainless steel is magnetic in nature and heat treatable to high strength. Therefore, it has very high strength to weight ratio with good corrosion resistance. It is used in aerospace component and springs. Examples are 17.7 pH, 17.7, 17.4 pH, etc. So next is duplex or super duplex stainless steel. So duplex and super duplex stainless steel contains both austenitic and ferritic in nature. Because of its structure, this grade offers benefits of both austenitic and ferritic stainless steel. Good resistance to pitting and pelvic corrosion. High strength and high resistance to stress corrosion cracking. Used in seawater system, heat exchanger and structural application. Some of the examples are UNS S32205 S31803, S32760, etc. So now we have discussed about the pipe material, how to select the pipe material, what are different types of carbon steel and the stainless steel material. So further moving on with the pipe dimensions. So pipe dimensions are given in size and schedule number. The mostly commonly used size of the pipes are NPS nominal pipe size, NB nominal bore, DN diameter nominal. In ASME B36.10 give more details about welded and seamless route steel pipe, and ASME 36.19 gives more details about stainless steel pipe. If you see this picture, the OD is this outer diameter, ID is this inner diameter. But what we say NPS, NB, DN is neither ID nor OD. It is the nominal diameter of a pipe which we define. Most people are confused with the pipe size 2 inch as the outer diameter of the pipe or ID of the pipe. But in either way, both are wrong. So NPS is just a minimal or nominal size which we define a pipe. And outer diameter of the pipe is always fixed. So pipe dimension is also defined in pipe schedule. So pipe schedule is a way wall thickness is mentioned. To simplify the ordering of pipe, ASME committee has developed schedule number which is based on modified Barlow's wall thickness formula. Definition of schedule number indicates approximate value of expression 1000 multiplied by P divided by S, where P is the pressure, service pressure in PSI, S is the allowable stress of a material in PSI. Example of pipe schedule is 5, 10, 20, schedule 40, 80, 100 till 160. And in SS it is 5S, 10S, 40S and 80S. So as I said earlier, pipe outer diameter is always fixed, and depending upon the pipe schedule or pipe thickness, inner diameter of a pipe will always vary. These are some of the examples of outer diameter. For example, if pipe is 1 by 8 inch or NPS 6, the OD will be 10.3 mm. If the pipe diameter is 24 inch or NBS to 600 or 600 NB, the outer diameter will be 610 mm. So moving further with the pipe fittings. So some of the pipe fittings are elbow, T, reducer, union, coupling, adapters, OLEDs, valves, cross, caps, swag nipples, plugs, expansion joints, steam traps, flanges. We'll see in further slides different examples of the each fittings. If you see here, pipe fittings are further classified. For example, flange. So flanges are further classified as SORF, slip-on raceways, WNRF, well neck raceways or threaded flange. Different types of valves is also there which we'll see later. Gaskets, elbows, 90-degree bend, 45-degree bend, 180-degree bend, T's, equal T, unequal T, caps, reducers, stub bends, couplings, union, OLEDs, etc. So further flanges are classified as threaded flanges, socket weld flanges, slip-on flanges, lap joint flanges. Lap joint flanges are a combination of stub bend and backing flange. Well neck flanges, blind flanges, reducing or expander flange. So picture presentation of the flanges. So this is well neck flange. You see this is the neck. Slip on flange. This is slip on flange. The pipe will directly go inside and it will be welded over here. Long neck flange, which will have long neck. Socket weld flange. There will be a socket over here. And the pipe will be welded over on the top of the flange. Next is lap joint backing flange. This is stub bend and backing flange. So ring type joint flange. So the face here, if you see, there will be a ring. Orifice flange. will have a small orifice, and this type of flange are normally used where we have a measurement with orifice plate, and there is a dummy flange to blind the pipe. So depending upon the faces of the flange is further classified into flat face, raised face, ring joint, tongue and groove, and male female type. You see there is a nothing over here. This is a flat face flange. This is also called as backing flange. This is used with the stub ends. This is raised face flange, commonly used in well neck and slip on. Lap joint, this is lap joint stub end with the backing flange. Ring joint, we have a ring over here. The gasket will be a ring type gasket. Male and female, this is a male a female flange, this is a male flange, and we have a gasket over here. And this is tongue and groove. So this is a tongue of the flange, this is a groove of the flange. Tongue and groove flange and ring joint flange are most commonly used in the heat exchanger. Dimension of the flange is given in ASME B 16.5 up to 24 inch, and in B 16.47 above 24 inch, and B 16.34 gives PT rating of the flange. So in annexure B of 16 of B 16.5 also have PT rating. So moving on to type of valves, we have gate valve, we have globe valve, we have check valve, plug valve, ball valve, butterfly valve, needle valve, pinch valve, knife valve. So moving with gaskets. In piping, gasket is a sealing material placed between connecting flanges. So to create a static seal, this will maintain the leakage proof sealing in all operating condition. Different type of gaskets are used to achieve the leak proof sealing between the pipe flanges. The primary function of gaskets is to seal the irregularities of each face of the flange so that there will be no leakage of service fluid from the flange joint. So three different types of gaskets: non-metallic gasket, and composite gasket. So moving on with the bends, we have 90-degree bend and 45-degree bend, and we have 180-degree bend. These are commonly called as elbows. So in 90-degree elbow, we have long radius elbow and we have short radius elbow. If the flow in a pipe demands low pressure drop, we normally use long radius elbow. And if there are no problem in the pressure drop, we use short radius elbow. This is 45-degree elbow, where there is a pipe routing has a 45-degree bend, we'll use this elbow, and 180-degree long radius elbow. So this kind of 180-degree are normally used in a coils. Let's discuss further about T's and caps. So T's are classified as equal T and unequal T. In equal T, outer diameter of the inlet will be same as the branch outer diameter, whereas in unequal T, this will be different. The branch outer diameter threshold, the minimum will be outer diameter of the inlet divided by 2 and one size less. For example, if we have 10-inch pipe, so 10-inch pipe will have minimum branch diameter of 4 inch. 10 divided by 2, that is 5, and one size length, that is 4 inch up to 8 inch. Then caps, these are the piped caps. These are used in the pipe end. So other pipe fittings are reducers, which is concentric reducer, eccentric reducer, stub ends as discussed with the flange earlier, and couplings. So couplings are welded coupling, the welded coupling and threaded coupling. So welded coupling are further classified as full coupling, which can be the pipe can be inserted from here and from here. Half coupling, which has only one side, which can be pipe can be inserted. And we have same full coupling threaded and half coupling threaded. Half coupling are mostly used in a pressure vessel. So we have different type of OLEDs, also a pipe fitting, weldolet, sockolet, threadolet, litrolet, elbowlet, nippolet, sweepolet, insert weldolet, brazolet, and couplet. So weldolet is most commonly used. Nippolate means we have a olet here and we have a nipple together. These are different kinds of olets. And unions. Unions are socket weld union. You see socket here and threaded union. So I hope you have enjoyed this video and you have found this video informational. So please share this video with your friends and don't forget to subscribe to my channel. Thank you.